All right. Hopefully that is working. Let me check. Yep. So I am going to be doing a little bit of live stream coding today. I'm going to try to just do some kind of interview coding practice with LeetCode. So what I'll be doing is I'm just going to go through and try some challenges that I haven't tried before. In this case, it's going to be this median of two sorted arrays challenge here. And I'm just going to be kind of coding through the challenge, describing what I'm doing as I'm doing it, what I'm thinking is ultimately just to kind of, prep for that sort of whiteboard interview coding challenge. So in the process of looking for a new job right now. So this is kind of just reviving that skill because it's been a while since I've had to code on a whiteboard. So let's get started. Median of two sorted arrays problem. So what I'm doing, actually, before I jump into that, what I'm doing is I'm going through, if I remember right, this is all category. In the past, I was going through and just sorting by like frequency, meaning like how often the problem is used in an interview. Median of two sorted arrays comes up pretty commonly. You can see it's toward the top of the frequency bar there. I don't have it sorted right now, but yeah, so like in the next video that I do of this, I'm gonna likely just choose the next most frequent one after that. And also this is hard, so expect that I'm gonna have some kind of false starts here and there. All right, so let's look at this problem. Median of two sorted arrays. So there are two sorted arrays, nums1 and nums2 of size m and n respectively. So they can have differing size, that's important, or it could be important. And we want to find the median of the two sorted arrays. The overall runtime complexity should be big O log m plus n. You may assume nums1 and nums2 cannot both. Okay, cool. So that's good. So we can always assume that there's at least one element in the array. They give us a couple of examples here. So in this case, the median, remember the median is like the middle number. So, if you have something like 1, 2, 3, 9, 100, something like that, your median in this case is still going to be 3. It's not your average, even though you've got like some big huge number here. It doesn't matter if this number is a million or something. It's still, your median is 3 because it's just the middle number in the sorted array. It's also like your 50th percentile if you're talking about statistics. Right. Also, I'm going to make sure I'm on the right. So for this challenge, I'm going to use, I guess I'll use JavaScript just because it's familiar and close. Also, really quickly, I'm going to switch this over to Vim key bindings. And I like solarized light for streaming. Looks like I probably have to refresh to get that. Second, checking out stream. Sorry, I have the stream open on another computer, and I was checking to make sure it was coming through high quality. Actually, it was just the side. All right, cool. So we've got nums1 and 2. They're going to be type array. And I think what we're going to end up with is you need to do something that's a little bit like merge sort, the merge operation in merge sort. So that is, we want to find that middle element. And actually, now that I just said that, so the merge operation is always going to be, and they're saying this should be log plus n, which is log of total set size, not just the size of one. So I'm not sure how best to approach this for like if I'm going to target that straight off. So what I think I'm going to try to do is run with that merge algorithm. Just trying to think if there's like a tree-based approach I can use for this or something like that. So like if we didn't have this as a, what's the word I'm looking if this was one single sorted array, you know, it'd be really easy, right? Because you just take the middle element in that. Or if it's like the middle, if there is no individual middle element, so if it's not divisible by 2, then you take the mean of the 2 middle elements, shown in example 2 over. So I think what this comes down to is we need to find, given these 2 lists, we need to find most efficient way to get to the element. So struggling to think of a good place to start attacking. Let's try this. So if I do for int sorry, not we're in JavaScript land. Let I equal 0, let j. I'm going to skip the terminating condition for a second, and the. I'm not sure exactly how I want it. And so, like, if I was merging, I'd have a const merged equals derate that, and I would just do I think I want let I equals here, let j equals 0 out here. I hate starting with a while true, but I'm just going to start with while true for a minute. And so when you're doing a merge operation, what you do is you say if let's see, if nums 1 is less than, we'll say less than or equal, this is a stopgap. Nums 1 is less than or equal to, sorry, this is nums 1 I, nums 2 j, then we want to merge dot push nums 1 I plus plus else merge dot push nums 2 j plus plus, right? So what that's going to do is we're always going to insert whatever element is lowest, and then we're going to advance that iterator index for that particular array. So what we can do, so this is not going to be log m plus n, right? So the other thing I need to do is I also need to do some bounds checking in here for a merged for the merge operation, right? So I need to say if j is equal to nums2.length or that condition. So in other words, if we've already iterated all the way through nums2, and if I to nums1 dot length or nums1 nums2 is less than nums2j is less than 1. I think there's probably a more succinct way of expressing this without having to have ifs, but this is going to be, so while I is less than nums1 dot length j is less than nums 2.length. We'll do that, and now we should have a merged. So what we should be able to do now is if merged.length 2 is equal to 0, then we can just simply return merged. Sorry, is equal to 1, right? So this means that we'll have a middle element. So odd number means we have exact middle element. So I always have fun with that, like because of integer division. So like if I have 1, 2, 3, 4, 5, let's say 5 divided by 2 with integer division is going to be, so 0 and 2, that's going to give me 3. Cool, just had to check that. And then the other thing is 1, 2, 3, 4. So with integer division, if I do divide by 2 here, I'm going to end up with element 2 again, right? Because I've got a length of 4. So 4 divided by 2 is 2, which gives me element with value 3. It's element 2. So I need to do that and that minus 1. So divide by 2 and divide by 2. So it'll be else return merged length plus sorry, divide by 2. Actually, get rid of all this. Sorry, I'm so used to Vim. I try to do Control R to put. That didn't work. So if I just put that, there we go. Middle. And then this will be divided by 2. So I don't like if this was, if I didn't have some guarantees like that these two arrays were, if I didn't have a guarantee that there was always at least one element, these have to do a little bit more like check to see if merged even has anything. So like if it only has one element, return that sort of thing. And I'd have to do that normally above this statement, but that should work. So let me just see first off, like I know this is an order n solution, or order plus m in this case. So I know that we're not meeting this requirement, but I just want to like do that to guarantee that I've got a functionally correct result. So I'm just gonna, so we've got this initial test case. I believe that means that we should be expecting 2 based on our examples over here. So I'm just gonna go ahead and hit run code. And our output's 1.5. All right, because we're in JavaScript. So JavaScript has this fun property that all numbers are floating point. So yeah, hopefully we'll fix that. No, okay, so where am I? So I've got getting back 1.5, which probably means that I have an off by 1 or something. So if I'm getting back 1.5, that's because I'm probably taking, I should have an array here at this point called merged, which should be 2 and 3. At this point, I don't have that according to this output. Getting an output of 1 which is 3 divided by 2. So that means taking 1 dividing that by 2, which means I've gotten off by 1. I'm not adding that third final element. Chances are that's because, so that's going to be in nums1, nums2. So that means chances are so chances are I'm exiting before I can actually add, I'm exiting my loop here before I can actually add this last element. And so my there was, I was thinking, oh, I'm terminating too earlier. I've got like the wrong Boolean operator. So I'm saying while I is less than, and by the way, that's not the case, but I'm saying while I is less than nums1.length, and j is less than nums2.length. So that should be fine. We should only bail when both of those are no true. Oh yeah. So that's actually, I was right. So this should be a 4, right? So while, yeah, so this should be an or. Because what was happening before was I was exhausting j. I was exhausting nums2, and because that was an and, this half of the Boolean operation was coming back false, which was negating the whole thing, causing us to exit the loop. So I think if I run code now, yeah, I get 2.0. Cool. So that's a good start. Let's go ahead and just try their other test case here. So I've got 1, 2, 3, 4. Great, so that's working. So I've got something functionally complete. And that's like, with these types of problems, usually the first thing you want to do is like, whatever the easiest thing is to complete like the functional requirement, this non-functional requirement of runtime complexity. Now that's going to be the tricky one. So what I'm thinking I want to do is I need to build up, I need to be iterating. Like I can't just do this wholesale iteration, like create this whole merged array in an order in time. Like I need to be iterating more intelligently through these lists. So if they're sorted, like I have a guarantee that each list itself is sorted, but no guarantee that they're ordered with respect to one, which is the thing that makes this challenging. So I'm thinking what I need to do is something kind of similar to this merge operation, but so when I say that, what I mean is similar to the idea of like I'm selectively iterating. So I've got 2 iterators, but like on each pass of the loop, I'm only really looking at one of the 2 iterators based on a comparison of the values. So I think what I need to do is something like, let me try to put this up here actually. So let's say I've got like one thing that's, I don't know, 1, 3, 5, 7, 7, 9, and another one that's like 2, 4, 6, 8, 10, right? So the median value that's going to be 5, right? Because the 1, 2, 3, 5, 6, 7, 8, 9, 10. And, or is it going to be 5 or is it going to be? Yeah, it's going to be halfway between 6, so it's going to be just to make sure 5 and 6 added together. So I checked is going to be 7 divided by 2, 5.5. So that's fine. This is a good number. So what I need to do is get down to the point of selecting these 2 elements and then dividing them 2. Maybe a little bit easier to just drop, let's say 10 for a minute, and selecting both after. So let's do that first. And so what I think I need to do is I need to like start iterating kind of like I do for binary search. Right? So for binary search, I know that I can get the median of each individual array by just grabbing the middle. Okay, so in this case, I'm going to start iterating at 5. I don't know, like I iterate at 5. Also start iterating over here at 4. At that point, what does it tell me? So that tells me I have the median of each of these two arrays. It also tells me the position of that. So like I can estimate the steps left to get this value. So like I can estimate, or I can not estimate. I know the number of items that are lower than 4 in this array. I guess at this point, like in this particular example, I also know the number of items that are lower. Well, so I know the number of items that are lower than 5 in this array. Maybe I can make assumptions there about what that is with respect to the number. What I'm not understanding though is what my stopping condition is going to be. So like if this is just a binary search, right? Like binary search is like you've got a target thing that you're searching for. Let's say I was searching for 4 here. Actually, it's a bad example. Let's say I was searching for number 2 here. I'd start at 5, let's say, and if I'm doing this on 2 different ones for some reason, start at 4 over here. 2 is less than both of those, right? So in this one, I divide my I by 2, which would point me at, on the next loop, I divide J here, which is 2 to start off with, by 2. That would give, sorry, yeah, sorry. My J here is not 2, it's so I divide that by 2, and taking the floor of that, which would give me 0, sorry. That would give 2, so that would find it. So like that sort of divide and conquer sort of approach work there. That works. I'm trying to remember. There's an algorithm called quick select. Quick select is good for finding the kth smallest element unsorted array, if I remember right. So quick select will it's basically like quick sort, where you have a pivot, you run through, basically swap elements that are smaller than that pivot so that they're side. Right, man, it's been a while since I did quick sort. Swap elements to the other side of that array. The other side of the pivot if they're larger. Sorry. So you start from below. Man, I need to review quicksort. Either way, I think that's the kind of approach that we can take here, but without the swapping and all that. So because we're already pre-sorted, I think there's some other mathematical property that I'm missing here on this one too. I'm not sure. Let me just start off with that kind of approach. So we know this works. I'm actually just going to hit submit so that I save this as well. Yeah, so like, wait, seriously? So this is funny. So in the description here, we've got overall runtime complexity should be O log m plus n, right? This is very, very clearly log m plus n, or sorry, not log, just linear. It's O m plus n, not log m plus n. I'm looping through both arrays in full, and then doing a little bit of magic here, which is funny to me. So what's hilarious though is that my solution, this order n solution, is already faster than 98.36% of JavaScript online submissions for medium sorted arrays. And even somehow better than 39.1, or sorry, than 62.55% of submissions for memory. That's sad. That's really sad. I'm still going to keep at it though. So, you know, even though LeetCode can't qualify or can't tell that this is an invalid submission, I'm still going to try to do the right. So, all right, so I'm going to take this kind of quick select approach. The quick select, I think I still need my I and my J. I'm going to do while something, while at the very least I is less than nums1.length. J, sorry, or J is less than nums1.length. Sorry, 2.length. J is greater than 0. Sorry, greater than or equal to 0. I always forget my Boolean operator precedence here, so I tend to wrap things in parentheses like this. So I'm just going to say while I'm in the bounds. And it's greater than. And actually, I is going to be nums1.length by 2, nums2.length divided by 2. So we're going to start off in the middle here. I really am not sure what this is going to tell me. Like, so I know that this tells me that my very first item is the median of nums1. The I item, I mean, is the median of nums1, and the J item is the median of nums2. But that's not the median of the whole set. So how do I get to that? I feel like this is going to be like a binary search tree or something. Like I need to be able to, like if I had a perfectly balanced binary search tree, if I remember right, the root node is the median. So trying to remember. Trying to remember algorithms for producing perfectly balanced binary search trees, and I've not like sat down and looked up red black trees, that kind of stuff. So this will be kind of fun. Definitely bit off a well, a hard problem for the first version of this stream. So a binary search tree, I'm going to keep using this data set. The binary search tree that's perfectly balanced is going to be something like 5. And then I'd have I think 3 goes here, and I think 7 goes here, and then of course I think we end up with so. Is it going to be 2 or some space in here, of course. Um, 2 and 4, and then follow that. 6 and I don't know, 8, something like that. More spaces. And then, so the only thing left that's less than I don't know if that's perfect though. There may be a better way to balance that. But either way, so like that would be a tree, an example of it. This is the sort of tree I think it's a tree that is balanced about its median. And if I did this correctly, I think each subtree is also the median tree, or as close as it can be to the tree, right? So we've got oh, actually, this is maybe a good example because like this tree here is not a full tree. The subtree is not a full subtree. So we've got 1, 2, 3, 4, and in this case the median 2.5. So it's the root of the subtree, in this case 3, and the one just below it, because I think it's because that's the heavier subtree, this root. Check over here. So similarly, I've got 6, 7, 8, 9. That should be 7.5. Yeah, and so this subtree here is heavier if I take this root. Similarly, in the case of 8.5, or sorry, 8, like this would be, the rule here is that for the 8, 9 subtree, 8.5 is the median, so it's the combination of, because it's not a tree, but then not a subtree, it's the combination of 8. I think that's what's happening here. What I need to get at. So I need to figure out how to build a tree like this from 2 sorted arrays. So this may be a balance, like a case of just keep balancing it the moment that I get to the point I have the root node and it has a branch above and below, or something along those lines. Like that may be my stopping condition. I'm just trying to think like how would I build this tree at all? So it's been so long since I've done like balancing binary trees. This is and I really decided to torture myself today. I don't know, just like procrastinating now. Let's see. So if I'm doing this, like I want to try to start. Well, let me think about it this way. Like for one array, how do I build a tree like this? For one array, it gets pretty easy because this tree, fifth element, so it's the middle. Take, it's the same approach that you take for binary search for iterating a binary search tree, or just for iterating in binary search of a sorted array. So like you start in the middle, you your next less than value is the midpoint between the middle value and the start. So in this case, it's going to be your next greater than is the midpoint between value and end. So it's 7. So then you've got this range from, you got like 1, 2, 3, 4 sub ranges now. So you've got 3 to 1, 3 to 5, 5 to 7, 7 to 9, and so you're just doing the same thing, recursively splitting them. So on the 3 side, you've got 3 to 1, 3 to 5, so you're taking 2 because that's the midpoint between 3 value, 4 because 5, and so on and so forth. How the hell do I do this for 2 different things, though? I'm guessing there's going to be some rebalancing step as I go. I think I was kind of onto it before. I need to be doing some tracking maybe of the actual median of the tree. Well, let me take it more. So I'm looking like kind of top down. Let me take it kind of bottom up, right? So in this case, if let's say I just start arbitrarily, so I'm looking at these 2 arrays lists. So I'm looking at these two arrays up here is my test case. So lines 1 and 2 up there. And let's just say I start arbitrarily at 1, right? So I start building a tree. I've got 1, and then I don't know. I'm just going to go through tree number or array number 0 or whatever. And so like the first thing I'm going to do is I'm going to see I've got 3 here, right? So the median of 1 and 3 is 2, right? Yeah. And so that's, I think it's still, I think that's a valid tree for what I want. So like if I had like a test that I was performing on the tree of like which like is this a valid tree based on the rule of either the root node is the median or the root node plus the node that contains the heaviest subtree. So in this case, or sorry, the root node alongside of that average with 2. So like this would be a valid tree based. But then like the moment I go to add the next one, so if I go to add 5, I get to here, and that rule no longer is correct, right? Because according to that rule, I'd be taking 1, because this isn't a full tree. I'd say, oh, 1's not good enough. I need to look at the heaviest subtree. In this context, it's going to be 3 subtree. You know, I'd be calculating my median is 2.5, or sorry, 1.5. Damn it, I'd be calculating my median is 2. There we go. When in reality, my median is 3. So what I would need to do at that point is rebalance the tree. So that would end up this. So I'd pull the new root out of that tree. And I wonder if this is always going to be the case where like I only had to step down the tree 1 level to do that. So let's keep going with this example, right? So now 3 is like I've got a full tree, so I just know for certain 3 is the median of this tree. So now let's keep going on. So I've got 5 here. No, sorry, I already added 5. I've got 7 next. So when I go to add 7, it would look like this. And at that point, so my median should be 4, because you know it's just this portion of the. So this is still valid here because heaviest subtree rule. Yeah, like this is still a valid tree, so there's no need to rebalance. And then I get to 9. And at this point, if I do that same test, I know that, well, first off, I just know that this is not a very well balanced tree because, well, it's just not a balanced tree, and I'm reading down, and I know there's a heavy subtree that's unbalanced. So like, I'm still thinking my median is 4 based on this rule. My true median should be 5, which means if I rebalance the tree, so this gets a little bit more complicated than last time. Like rebalance the tree just real quick. So this is the point at which I had to rebalance before. And it was really easy because I just would pull this out and chuck 1 as a subnode. But now it gets trickier. If I want to have a truly correctly balanced tree with 5 at the root, the operation I need to do is like a lot more complicated. I need to, I mean, I could in theory, I guess, just do something like, oops. So this would be what did I have before? I had 1, I had 3 at the 5. So like I could do a similar sort of thing where doing this in ASCII sucks. There's one time when whiteboarding definitely. Oh. I do have a stylus. I should probably just do that. It's all right. So that's good, but it's not. Actually, is that as balanced as it could be? Yeah, that is as balanced as it could be. I was thinking we had more complicated shift something from this side of the tree over to that side of the tree or something. But so far, I don't actually need to do that. So now I'm actually truly balanced. Still not full, but oh wait, I'm not full, but I am symmetric. That's okay. So that's good. So like that approach works for rebalancing it, but like it's still very order n. It's way worse than order, isn't it? Well, way worse. I think it's certainly not just a single linear pass, which a linear pass is better. So like, how do I improve on that? So like if I'm rebalanced, no. So if I had I'm just trying to think of a different approach to this as well. Like, or well, I was starting to think of a different approach to this, which is like based on the number of items remaining in each. So like a really trivial example is like 1, 2, or 1, 3. If I start here, if I start just looking only at this array, so let me just do better than this. 4, 5, 6 or something. So if I start looking here at the middle value, I've got a candidate of 4. I'm trying to figure out is so like I know I've got an array of length 3 and an array of 2 for for a total of 5. So what I know right now is that 4 is greater than 1 element of. So that's actually, I think this is probably the right way to go about it. Shit, I'm finally there, I think. Okay, so I know that 4 is at least bigger than 1 element of the array, or of the combined merged array, and it's smaller than 1 element of the combined merged array. But if I go here and let's say I start with 3, I also know that 4, my midpoint, is larger than 1 more element. So I can say 4 in this case. Oops, let me do it down here. So at this step of the loop, if I first pass, like I just take this middle value from the first array, and I can say that 4 is definitely smaller. Sorry, 4 is definitely larger than at least 2 items, and 4 is smaller than at least. In this case, because I've got an array of length 2 here, say at least 2 items. So like right now I can already say, bam, 4 is my median. Right, so like if I write this out, let me just make sure 1, 3, 4, 5, 6. Ta-da, 4 is my median. So I think that's actually the approach that I need to take. So let me try something a little bit more complicated. This one up. This fun one. So yeah, forget about this tree crap. I think this is actually the right way. So I've got 5 and 4. Let's get rid of this crap. Total length of 9. And I can do, so if I start off iterating here, I can say 5 is greater than at least, so I can say at least 2 elements of this array, and then if I start at the midpoint of this, I can say at least 2 elements of this array as well, so 4 elements. And this has to be at least, unless this is an exact match. So like, actually, even if it is an exact match, I don't think it matters, because I could have like multiple 5s and stuff. So let's just, I'll just keep going with, and I could say 5 is less than at least 2 elements from this array. I can't say anything about that. So what do I want to do? So if I have 9 elements and I know, I mean, actually, I could probably stop there because I can say, actually, can I stop there? I wonder. I just don't know if I can stop there because I make 5. So let me change this example. Cruel. Well, that's less cruel. Let me change this example to be one where, let's do this. 1, 2, 3, 4, 5. 5, 5, 6, 7. 10. So I've got 5, 1, 5, 6, 7. Is that right? So yeah. So I've got 5 and 7. So 12 total elements. I start off here. I'm going to start off saying 3 because I'm going to start at this one. I can say 3 is greater than at least 2 elements from this array. And if I start here, I can't say anything about what 3 is bigger than in this array because I don't. 7 is greater than 3, so and actually this is greater than 2, but that's fine. So that's only 2 elements, and then I can say 3 is less than or equal to at least 2 elements from this array, and 1, 2, 3, 4 elements, so 6 elements in total. So straight away, I think that means 3 is my median. Does it? So 3 is less than or equal to at least 6 elements. I've got 12. Sorry, no, it doesn't because so my combined merge thing is 2, 4, 5, 5, 5, 6, 7, 8, 9, 10. So my median here should be 12. So my median here should be 5. Right, because this is at least 6, and so right now it's telling me that 3 is anywhere from, like, if I've got, let's carve this up as a space. Space there. Right now, this is telling me 3 is anywhere from here to 1, 2, 3, 6. From here to here, if I understand. So 3 could be my median. It's not necessarily my. This is the range it could occupy. Before I move on, though, I should look at 7, right? So I can also say that 7 is greater than or equal to at least 3, 4, 5, 6 elements, right? Because 7 is here, and I know that there are 3 elements smaller than my sorted array. We've got 3, which is less than 7, so I can say it's also less than 3, 4. So there. So 1, 2, 3, 4, 5, 6, and then I can do 7 is greater than or equal to at least 1, 2, 3, at least 3 elements. So map up here, 7 is going to be push this over here. 7 is going to be greater than or equal to at least 6 elements. So 1, 2, 3, 4, 6. Less than or equal to at least 3 elements. So 7 is somewhere else. So now what do I need to do? Or like, how do I step? If I have this range for 3 and 7, I think what this tells me is that this range overlaps here. Like, I don't know anything about. Do I know anything about these items here? Yeah, actually. So I know that, like, for 7, I need to step in this direction, because I know that I'm above the range for which I have a median. 3, I don't think I want to step yet on this one. Think for 3, because this encompasses my median, right? So 1, got 12 items, right? 1, 2, 3, 4, 5, 6. So my median is going to be, oh, actually, that's interesting. So my median is going to be that. So I'm pretty sure because this range encompasses my median, though, I don't want to step 3. I'm not really sure what to do about this. I think I'm going to end up needing to store data structure. I'm not sure what data structure that's going to be yet, but let's carry on. So if I want to step, question is, how much do I step? I think because this is a log n or log m plus n in this context solution, I think what I want to do is just your standard divide and conquer. So because I'm at this middle value here, say this is j. So I think because I'm at this middle value for my step 2, I want to do, I'll leave I where it is, I think, and we'll leave j, we'll move j to be whatever's the middle of this and the start. So I'm going to just mark this with say that it's been visited. And in this case, j is going to be 5. I think I'm not sure. This is kind of intuition at this point. So so for this one, I know I can say, so now 3 is less than or equal to still at least 2 elements because 5 is greater than 3. 3 is greater than or equal to, sorry, this should have been greater than or equal. 3 is less than or equal to at least, so crap, this should actually be, technically because I have these equal twos, should be at least 3 elements. I'm going to leave it as it is for right now. I probably need to delete one of those equals in inequality comparators. Either way, it's going to be greater than at least sorry, one sec. It's going to be greater than that, at least 2 elements. It's going to be less than 2 elements from here. But because we've got, where am I? 5, 3 is less than 5. I can also say now that 3 is also less than everything in this array, right? Because so that's going to be 1, 2, 3, 5, 6. So I'm just going to switch this over. Sorry. 8. Let me just fix this for a second. This is bugging me. It's getting me distracted. So in this case, 3 is bigger than at least. It's smaller to 6 elements. 7 is 2, 3, 6. Smaller. Okay, cool. So yeah, so we're gonna get rid of the sign in that. Anyway, so then I've got 5 here, which this really should be like the item at index whatever rather than 5, but take this off at least. Where am I? So at least 1 element here, but then because 5 is also greater than 3, I can say I get 3 more elements there. So for 5 is less than at least, let's see. Crap, this does need to be an equal to, doesn't it? That's all right though, because I'm just trying to find these ranges. It's not, I shouldn't be that strict, but 5 is greater than 1, 2, 3, 5, but then also because 5 is greater than 3, say 6, 7, 8. So now I've got whatever this data structure ends up being. I've got a 5 in here, and this is 5 array 1 element. I'll do it. So let me update my 3 first. 3 is greater than, sorry, 3 is less than at least 8 elements. So 1, 2, 3, 4, 5, 6, 7, 8. So now I can say, so I'm revising this here, right? 1, 2, 3, 4, 5, 6, 7, 8. So actually, sorry, to here. So I can say definitively 3 is not my median, so I know I'm going to need to step 3. And then for 5, 5 is greater than at least 4, so 2, 3, 4. So I know 5 be from here to less than 8. 1, 2, 6, 7, 8. Ooh, that's interesting. Wait. 1, 2, 3, 4, 5, 6. Did I screw something up? Or did I locate 5 exactly? I think I located 5 exactly. Or did I screw something up? So 5 here is 5 is smaller than. I think I screwed something up. So here I've got 5 is smaller than 1, 2, or 5 elements here, but I can't say anything about 5 being smaller than seen anything. So I just screwed that up. 1, 2, 5. So this should be a 5 here. Uh, 1, 2, 3, 5. This is definitely going to be like way longer than I would expect it to be for coding interviews. So already probably blew it, but that's all right. I'm going to see this one through. I think, not sure how long I've actually been going. I probably should have set a timer. Okay, so I believe 5 is now there. So 5 kind of wraps our median nicely. Let me just double check this again. So I know 5 is less than, sorry, 5 is bigger than 1 element here, but then it's 3. So yeah, it's, okay, cool. So because I've narrowed down E to be not containing a range that doesn't contain my median, I know I can iterate in this direction, or the first array in this direction. So for my step 3, I'm going to, so also, by the way, my 5 is the median, so the range that I have for 5, so I'm not going to step that because that may be what I need. So for 3, I'm going to mark that visited here to 4, just because it's halfway between 3 and. So let me just copy this junk here, life quicker. And so this is going to be 4, 4, 5, 5. So this now, and so I can say 4 is greater than easily 3 elements over here, but then I'm comparing it to 5. So I can't say anything about what 4 is bigger than. So I'm going to say 4 is bigger than at least 3 elements. 4 is less than at least 1 element here, but 4 being less than 5 means it's less than everything over here. So 1, 2, 6 elements here. So 7 elements in total. How can I update 5? So I can now say 5 is less than, sorry, 5 is greater than 4. So now it should be 4 elements over here, over here. So 5 elements in total. It's bigger than at least 5 elements. And it's less than, so because 4 is less than 5, I can't really say about 5 would be positioned over here, but say it's less than 2. So that stays the same. So down here, I just bring this up to that. Or say it's bigger than at least 3, so I can say somewhere in there. Less than at least 7, so 1, 2, 6, 7. So now this is confusing me because I think this should be less than or equal to. And I think I've gotten off by 1. So like if I say it's definitely less than those 7 elements, I'm excluding. Yeah, actually, I think that's okay though. I think it's okay to exclude that. So we'll see. I'll probably end up having to tweak that later. Either way, because my 4 is now definitely not at the median. I need to iterate that, and so and because it's below the median, I need to visit the next one. So and it's the only one that's left. So I'll go there. So in this case, and this is gonna be like 5 from array 0 element 0 1. So 5 array 1 1 0 4. So 5 0 4 is greater than 1 2 3 4 elements there. And now this is interesting because these two are equal. I think I can say it's greater than at least, or it's greater than is the wrong term, but it's like above in terms of at least 1 element. So I think I can say 5 elements, and say over here it's less than 0 from the top array, 5. Yeah. Which gives me, set this range. And I think I may be missing something here because like the number 5 being equal to a number that I already have in this. I wonder, like there's no guarantee that I'm not going to have duplicate numbers. Like there's no guarantee that all values are distinct. So I think this is a valid test case. But this may throw an extra kind of wrench in the works or whatever. Just because like I may be able to actually start from this one. Not really sure. But I'm kind of treating this more as a structural problem than a numeric problem at the moment. So I'm just kind of like trying to find these ranges. So I'm gonna kind of continue with this approach and see where it leads us. So it's bigger than at least 5 elements. So 1 2 3 4 5. And it's less than at least 5 elements. 1 2 5. So like this is telling me that 5 is my median, just based on this step right here, which is correct, right? 1 2 3 4 5 6 7 8 10 12. Yeah, so like 5 comma 5 right here. These are the middle 2 values. And so how many steps was that? There was 4 steps. What is yeah, that's right, because log base 2 of 12 is going to be. So I think this works. I think this is the algorithm we need. So let me figure out if I can freaking code this thing. This is going to be a joy. Oops. I'm not entirely regretting this choice of problem for the first version of this stream, but it would have been nice to have something a little straightforward. Okay, so what I want to do is I still have this right. I think this iteration is still correct. So like I'm just iterating until there's almost certainly a better stopping condition, but for right now I just like want to make sure my iteration is safe. So I'm just saying like iterate while all indices are within bounds, right? Specifically while either index is in bounds, not both. And then, so I've got this number. Let's see. I'm probably going to do, I think I'm going to try to take this pretty much verbatim. So I'll do const ranges equals actually, I'll do this for now. I'll make it a I think I'll make it an object. I think this is kind of like forcing me to treat. If I make this an object, so what I was thinking is basically this is should this be an array of ranges or should it be like a hash map of ranges? And the main difference would be like the identity issue. So I don't even know that I need to like. I don't even know how much of this I need to store, but I assume I need to store all of it. And so like if I make this into a hash map kind of thing, dictionary or in this case a JavaScript object, the identity of the value 5, I either need to disambiguate that or I need to allow like this step, I need to allow it to treat both 5 as I guess I can disambiguate it pretty by just including the ID of the array and the index of the array. Actually, yeah, that's what I'll do is I'll store them based on indexes rather than numbers. And I'll store each index based on, so const ranges. I also need to know what my median values are. So const median and so nums1 plus dot length plus nums2 dot length 2. So if it's even, my median x's are 2. If it's sorry, if it's not an even number. Otherwise, it's going to be, if it is an even number, it's going to be math.full this. Let me do it this way, actually. So const point, just to save the math. Sorry, muscle memory. Every time I hit Control R, it refreshes the page. It doesn't. It's not accessing a Vim register. So probably a nice way to do this, like, yeah, actually there is. So JavaScript has some fun stuff. Like if I remember right, if I do midpoint, doesn't matter actually which way I shift it, shift 0. So let me just double check that. Let's say I have a number like 2.5, a shift 0 equals a false, and that's because a shift 0 is going to be 2. So it forces a new integer. So this says, are we an integer? So now I can do is integral is the wrong thing. Oh yes. If it is an integral midpoint, then this is equal to midpoint. Otherwise, this is equal to oh, why are you doing that? That was probably stuff I didn't want to show on stream. Lovely. I'll probably have this video private now. Fun. Crap, I need to check on that. All right, I should be back, and yeah, sensitive they can't, so should be good. Sorry for the interruption. So yeah, anyway, I was just checking. Is my my midpoint, like I'm being too finicky about this right now. This was a job interview, and I was writing on a whiteboard. Like, there's no chance in hell I would actually be this finicky. So this is probably an example of why I should be using a whiteboard and not actual code. But anyway, so my midpoint here is going to be midpoint shift 0. I think the shift has precedence over in subtraction, but -1 midpoint shift 0. Darn it. Try to be consistent in my shifts. Oops. Okay. So what this tells me is, yeah, this gives me like the m's in that range that I had up before. So these ranges, it tells me where my m's are. And then let's see. So while I'm iterating, I'm going to say const I range ranges So I think what I'll do is I'll do ranges I here for indexing into this thing. Or sorry, just realized that I just don't like calculating the same thing over and over again. So tend to have a bunch of little kind of helper variables for readability. So anyway, so this will be 0 to total length -1. That should work, and a const j range is going to be j. I'll say num1.length nums1 plus j. So what that does is just gives me an offset for a number that allows me to make sure that the ranges for elements in j don't collide with the ranges for elements in I. Or I'm using nums1 and I interchangeably, j and nums2 interchangeably. Okay, so I got my I range, I got my j range. What I want to know is I want to calculate updated version of that. So I want to say so for I, if I lower bound equals so I lower bound. So I'm always going to be saying, like in this case, step 1, this is greater than 3 of these elements, or 2 of these elements, at least 2 of these here. So I know that. So this is actually going to be a let. I lower bound is equal to I minus 1. Let I upper bound be to plus 1. No, sorry. I upper bound is going to be to what? So it's going to be nums1.length minus I. So in this case here, it's going to be 2, 5, 2. So sorry, no. Yeah, 5 minus it's going to be 3. Let's add to that because I need to exclude the element itself. So yeah, so and we'll do for j, same thing here. We'll just initialize that. And now what can we do? So now we can say, now we want to update I based on what j tells us about I. So if j is greater than I, so in the case where j is bigger than I, which was what we had in our first example step here, this tells us that our I is less than j and everything above it, right? So this influences the upper bound, upper edge, closing bracket, if you will, for I. So if j is greater than I, num elements above I is equal to I think it's just number of elements above j and j. So it's 1. Similarly, if j is bigger than I, what does that tell us about j? So j is bigger than I, that means that j is bigger than I and everything for I, so that's going to num elements below j equals, sorry, this should be plus equals. Equals num elements below I plus 1. I'm just going to write this in a slightly more normalized form. So I is greater than j. I believe we have the opposite, so num elements below. Wait. Should be like that. So if I is bigger than j, the number of elements that are smaller than I, they're smaller, it's going to be smaller than j plus j itself. And if I is equal, so if the numbers are equal, I feel like if the numbers are equal, we're probably at our median. But I don't know if that's true, because like I could have if the numbers are equal, we are at our median, because we otherwise we wouldn't reach them both at the same time, I think. Trying to think of a counterexample for that. I'm going to say return 1 I, because I'm pretty sure actually, can I say that or not? So I was thinking, like, what does it mean though if these two are equal and like one of them is the median and one of them is not? our actual medians. I don't know, like in this case, all the way back up here. So 12 items. So our median is 5 because of these two 5s together. But like, what if this was actually 6? I wonder if I'd hit like 5, 5 here and think, oh, hey, that's my median, when in reality my true median should be 5.5. So maybe I can't actually do that. So what does it actually tell me though? So it actually tells me that there's all the way at the end. So when they're equal, this one, I is bigger than I array that I is actually bigger than, but it's also bigger than everything here. So number of elements below I is equal to number of elements below J. Number of elements above I equal to also number of elements above J, right? Because they're equal, so yeah. Same thing, except just oops, crap. Except I did all that in the wrong freaking branch. Okay, so I've done all that. And now what I need to do is check if, so now I need to say ranges, sorry, I range equals num elements below I, elements above A. Ranges equals I range, ranges J equals J range, sorry, J should be nums one dot length plus J equals J range. Sorry, I was just checking the stream to make sure it was still up and running. And then, so I've stored off the ranges, and now I want to check to see if either one of those is equal to my median. So if I range, sorry, if I want to do if is integral I range 0 equals I range Actually, how does that work? So like I'm saying there are 3 items below, say I, 2 items below I. Value, what am I storing there? Yep, we're getting off by 1. Because number of elements below I is equal to I because I starts at 0. So if I've got here, it's going to be 2 elements that are low I. And then number of elements above I. So 0, 1, 2. 0, 1, 2, 4. So, but I've got 5 total elements. 5 minus 2 is 3. Should be minus 1. So basically it should be like if the number of items below be like that, right? Nums 1. So if the number of elements below is equal to the number of elements above, on our midpoint, same thing. Don't get R. Same thing here, except this is J. Crap. Also, nums 1I here 2J. Nums 1. If it's not an integral midpoint, in other words, like if we have 2 items that we average together, so we get an even. Actually, it doesn't matter, does it? It's integral or not. We're always going to have the equal above and below. Where it matters is in what we return. So if is else. Now that I've done all that, I'm wondering if I need to even store the ranges at all. Yeah, I do, because I'm Wait, do I? I don't think I do. I'll look into it in a minute. If is integral midpoint, nums to j. Otherwise, turn. Oh, this is tricky now. So what happens when my midpoint is yeah, I'm doing this wrong. So it's not just if the number of elements below is equal to the number of elements above. Because I could have a situation where like perfect, the range is like perfectly balanced and spans like a wide set of things. It's, if so I want like I may have a range that equals 1 total. So like range to index. So number of elements below. Sorry, it's just gonna be like if I range 0 or whatever, if num is below I equal what am I trying to say here? It's if we have 1 less than the in the case of the integral. Or actually, wait, so median indexes, that's what I want to do. So if number of elements below I equal to index, the low index, so right, so 1, 2, 3, 4, 5, 6, and my median index is 2, 3. So yeah, if the number of elements below I is x, above I is equal to my lower median is 1, I think. So if my lower median index is 2, I'm just trying to figure out, like, do I have 1 element, basically, in my range, right? So, sorry, I probably should have verbalized that before I went on that. Tangent. Do I have 1 element in my range? If I do, know that the number of elements below that element is going to be equal to the 0. Either So in the case of an integral midpoint, it's going to also be equal to that midpoint. Otherwise, if it's not, it's going to be equal to plus 1. That is a really ugly conditional, though. So, like, bear in mind, if I was actually writing real code right now, I'd be looking this algorithm up, and I would not be trying to do this from first principles. So just remember that this is a hard problem. Okay, and then so this handles the case of I. I actually don't really care, do I? I just care, like, do I have both the elements that I really want? Like have I narrowed down my I or my J to be my median? So I need to do like overlaps median. Yeah, let me break this out. This is a horrible misstart, but const overlaps median equals function range size indexes and a range will overlap the median. Wait, I've got the number of elements in the range, the number of elements outside of the range. So const outside elements equals range 0 plus range 1. Const num inside equals size minus outside elements. I'll say outside. If start range is equal to range 0 plus 1 const and of range is equal to range minus 1. And then I'll say if num inside, sorry, if median indexes dot length and if sorry, if the start of the range is less than or equal to the range greater than or equal to median. Turn true in that case. We overlap the median. If median indexes are equal to, if we have two median indexes, our start of range is less than or equal to the start of the median range, end of the median range, we can return. Now, do we want to count a partial overlap? If we do, I just need to do. I'm going to say I do want to count a partial overlap right now. Okay, I ran into that down here, right? And so, or up here, yeah. So like with my 7, where did I do that? I visited 7. For step 2, I kept myself at 3, and then I decided to move away from 7. Maybe that was, well, I guess that was the right approach for this because it was a partial, had a complete overlap. So maybe what I need to be doing is turning like a score. I don't know if this is necessary, but so I return 0.5 if I have a partial overlap. Yeah. So I want to check, am I overlapping with the median? I also just need to know, like, do both ranges tell me the median? So, so in this case, I want to say, start of start end num outside I. So my start and end of the range. So if median index is dot length is equal to 1, and median index is dot length equals 1, and start of I range end of I range. I guess I'll just go full on brute force here. Nums1, nums2. Return nums. Reading that link. Start of J range. Yep, good there. Same case. So now find one. So now if we have two, there are like 4 different conditions that can satisfy this. So if start of J range is equal to median index is, sorry, let's start with I. So that means that similarly, we can have the median covered entirely by J range in nums2. There's got to be a more elegant way of doing this. Kind of just trying to get something that works right now. So start I range and this is ugly. There's gotta be a better way to express this. So this tells me I have only one element selected for I, one element selected for J, my I element to that the median, the lower median index. My J element is the upper median index, and so then I do that. Otherwise, I could have the opposite. So all right, cool. So I'm just going to return null if there is no, if none of these cases matches and we don't know the median yet. Null it is. Just going to double check a couple of things here real quick. So J, nums2, nums1, nums1 I, nums1 I, J range, nums2, nums2. This is where I is equal to the lower one, so start at I range. These start and end values are equal to each other, so it doesn't matter which one I use. So start at I is equal to the lower one, start at J is equal to the upper one. I'm going to return I nums to J. This is start of I is equal to the upper one, end of J or start of J, lower one, nums to J, so that all corresponds correctly. Like looking up the J index in num1 or that kind of thing. Cool. So now I can just say get median of if exact range. Otherwise, that should return null. This should be returns 0 if no overlap with median, returns 0.5 if partial overlap with median, returns 0, or sorry, 1 if complete overlap with median. Okay, so back to our handy dandy while loop here. First thing I want to do is say get, what the hell do we call that? Get median if exact range, and then we pass range, num size. Okay. Is that not right? Yeah, that's right. Pass I range, j range, nums1, nums2. What do we call that? Total length. Const if median overlap is equal to degree of overlap with median I range total length median indexes if am I above or below though? And I range 0, so the start of my range is, if the start of my range is below index oh, this is weird. How do I calculate what I want my I to be? So I isn't just equal to I divided by 2, because I may have already visited something. So I may have like stepped down, then stepped up from that. So I want to get the midpoint between the previously visited I. So I probably need to do prev I equals I. Let prev I equal 0. Let prev j equals 0. So, oh, come on, get out of here. I hate it when my Vim hotkeys like overlap with my browser hotkeys. Time is it? Oh wow, it's almost 6 o'clock. So rather than this, it's going to be I is equal to prev just realizing prev I equals I, that's not, just do it there. So I have to do like const temp I equals I. Prev I minus previous I divided by 2 math dot for of that. this is going to. Sorry, my brain is just slowing down right now. Sorry, I messed up. So I did this wrong. So this is still want else if this, but then if I range 1 is greater than this. I'm an idiot. I need to do this like const median indexes. This will like solve so many different things. So lower median index equals is integral that's right. If I'm at 5 items. Sorry, I forgot. Yeah, 5 items with like 2.5, so that could be 1, so that should be just like that. Yeah, okay, should be like that. And then I might need to go back and do some fixing to that. Just gonna pretend like this was over here. Should fix this now. Get median if exact range. Get rid of these only ones. Median covered entirely by I range. Cool. So that should. I think that fixes at least this case. Entirely sorry. Something up there. Yeah, get rid of that. So by just like always assuming I have two median indices, I cut out a bunch of stupid special cases that I really just don't need. Like all I'm avoiding with those is divide by two, but adding a bunch of branch misprediction or something like that. So yeah, that should still be fine. So I now have return my median if I know it. I calculate the degree of overlap. In reality, I probably want those, like I probably need to, like, overlapping, am I below or am I above? Like if I'm not overlapping, so like if I do if overlap, then overlap J. Next thing I need to know is am I below or above, right? So and range I I range 0. So if my lower value 0 is greater than my upper median index, then that means I'm above. So in this case, I'll have const temp equal I. How do I do that? I previous so wait a minute. So I is equal to math. Something like that. Right, so whatever. No. I'm confused here for a minute. So like if I need to step toward the middle, the first thing I need to do, so like on the first paths, if like assume this is iteration 0, I'm stepping toward the middle, then that means like previous I is 0. So I'm stepping, just taking I minus previous I equals I minus previous divide by 2. If though I had stepped up previously, I'm now stepping down. Previous I is still going to be less than my. If I'd step down though, and I now need to step up, my previous I is going to be greater than my current I. But that should still be. So as long as I just check on math.abs. So I was right before. Okay. I think. Oh, the directionality of this is annoying. Previous I is greater. Yeah, I'm just picking out the midpoint, right? It's midpoint. If I range is below the median, oops. I'm just an idiot. I don't think I need that at all, do I? Because it's just like if this is entirely above the median, if the larger value entirely below the lower median, then still I'm hung up on this midpoint stuff. I think I want to do -1 plus 1. So like that. Trying to. This is annoying because it's like I need more than one variable for this, don't I? I need like my previous higher I is lower, or something like that. Because what I'm struggling with right now is if I do 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, let's say. Let's say I've visited 6. So let's say I visited the 6, and I decide I need to go visit 9. And now let's say I need to step toward the middle. So if I'm stepping stepping toward the middle here, the previous I works fine for that. So actually, forget I said that. Let's say we need to step toward the previous I is not going to work. We're stepping toward. Oh, but never mind. I was about to say, oh, but the number of steps that I need to take does work for that. So like, I have visited 9 there. Would have visited. You know, I would have visited. Sorry. So like, let's say I'm stepping down here. 5 minus 8, the absolute value of that, so 3. And subtract 3, is that right? From the current one, is that what I just did? Oh wait, sorry, divide by 2. The floor of that would be 1. So like I then go visit. Sorry. I've been live streaming too long. So I do, if I've got my prev I equals 5, my I equals 8, I have minus 5 equals 3, divide by 2, equals 1.5, and the absolute value of that. But that's wrong. Like what I want to do is I want to get either 7 or 8, probably 7 as like point between these two. Why am I forgetting the equation for it? Oh, it's just, yeah, it's just x plus y divided. Right, so it should be previous I plus I divided by 2 before that. The problem though is like, so let's say I do that and I decide I need to step up. This is a poor example. If I do that, let's say for some reason I did that and like there was a bunch of values in between this, in these two, like, I don't know, something like that. Just breaking my example a little bit. Let's say I decide I need to step down again. I would need to remember I would need to remember the 5, basically, this index. And so what gives me that index? I need to keep track of it's annoying. So I need to keep track of like the step range or whatever. So like I've got previous lower I equals 0, previous upper I equals nums 1 dot length is 1, pre lower j equals 0. Okay, so now I need to step toward the middle for I. So if I need to step toward the middle for I, that's going prev upper I equals I. I equals I plus prev lower I. like that. Okay, I don't know why the hell that was so hard. Similarly, I'm going to say lower upper. So that's going to be the midpoint between those two. I'm going to step to that. Cool. That fixes that. I also need to figure out if these are else's. Like this, these are mutually exclusive anyway, just all on their own. So I don't really need this there. But for the J, if J range is greater than upper, just that. But I still feel like I'm mixing or missing the case where it's like the lower range, or sorry, where the range is basically the median range. There we go, is split by one of the two. And so I'm worried that if I end up in a case where like my I range, let's say, is splitting the median, and my J range is not, or sorry, and my J range is as well, and like one's on the lower half and one's on the upper half or something along the lines, I'm gonna end up in an. Thanks for the feedback. I am gonna butcher your name if I try to say it. Severiano, I hope. Thanks for that. I really appreciate it. And thanks for watching. I'm gonna try this as it is, and what'll happen is it'll time out if I hit the. So let's leave that alone. So I don't need this stupid degree of overlap median anymore. And I'll keep that get median range thing. I don't know, screw it. Let's just run the code and see what happens. Sev or Sieve? Shorty or longy? Oh, did I define that as a const? Of course I did. Time limit exceeded, so I think I already hit that infinite loop. So let's just look at what's happening here. I'm going to just use this example to try to get it through here because it's been a while since I've actually tried to run this through. So bunch of initialization. I don't need this merged thing anymore. Pretty sure. Yep. I and J. got our total length, our integral midpoint thing, which I'm still using that just here. Helper. Oops. Some more initialization. Okay, so while our indexes are within bounds, we set up our initial I range. And so our initial I range is going to just 0 to total length minus 1. So that's the total length of the two combined arrays. Our J range is similarly going to be 0 to total minus 1. And so I actually need to make sure this is working like I expect it's working. This is some JavaScript trickery that in a normal interview, I would probably, like if this is a whiteboard, you know, I would just be like, I'm assuming this is working like this, but right now, because I'm actually trying to run and test the code, I want to validate that. So say const I range equals ranges, and then I'll say 0, or would help if I did array. Okay, so that does work like I expect. So that's not anything that's causing a bug for me. And I'm just using this this length here to kind of disambiguate my num0 ranges from my 2 ranges. So elements below I is equal to I itself, which is correct as far as I'm aware. And elements above I is equal to everything above I. So like the number of in total minus I, minus 1 more though, because we have to remove I from that list as well. Same thing here for J, no silliness where I accidentally J where I. If the actual number at I is less than the actual number J, use that to make some inferences about the number of elements that are greater than I. We also use that to make some inferences about the number of elements that are less than J. Similarly, the reverse is true here. I think like if this is a problem, like I'm basically my advancement of my iterator values, my I and my J is not correct. So I'm going to kind of just skip ahead down to here. Get median if exact range. So what I assume is happening through all of this is I've got 1, 3, 2. I've got I range equals 0. So 0, 2. J range equals 0, 2. And I should be starting off with I equals 1, J equals 2. And then I should be choosing a range. So with I equals 1, I know that my I range is going to be 0. There's one element bigger than it from based on this, but actually it ends up being 2 elements bigger than it. And my J range should be 2. I have 0 elements. Sorry, 1 element smaller than it because the one that I is smaller. And my I believe I should be able to. I should be saying that there are. Actually, how am I updating? That's probably my bug. It's one of my bugs. So j equal to 2, I know that I've got one element smaller. But I can't make any inference about it, so I should be saying something along these lines, like 0 elements are larger, which gives me something like, so for 1, I should have a range that looks like this, and for 2, that these are the element, not the index of the elements, not the index. I should have a range that's like x well, it should still be that, right? So, but how do I figure that out from this? Got some flaw here. Oh, sorry, I'm mischaracterizing what these actually mean. So I have 0 elements that are known to be bigger. So there are at least 0 elements bigger than j, 2. What that means is there are 0, like I'm really carving this into 3 ranges, right? There's the number of elements below my range, the range at which I believe j might be within, and then the number of elements above it. And so this is 0 elements above it. So that makes sense. I wonder if my code's reflecting that out. So in this case, so when I'm looking at j, I'm saying 2 is greater than 1, and 2 is greater than 1. All I can say is that, oh, yeah, I think it's my initialization. So my initialization up here needs to be because I need to be saying, like, this basically should be saying like this. So right, okay, so that's the number of elements below the number of elements above. It probably would be better if I just inverted this and expressed it as range. That's fine. Change it. I don't think that makes sense, though. Second, so for I, 0 elements smaller than I, 2 elements larger. So actually this should be like this. J is 1 element smaller. Don't know that it's bigger. So that's correct. And so we're going to iterate. We would want to iterate J. Ah, that's where my bug is. Okay, so we would want to iterate J, but we can't. Or would we actually? Because this overlaps the median. So we actually would want to iterate I. So let me look at this here real quick. I'm really like I'm trying hard not to do any debugging. So like if I was not writing code as if I was in an interview, what I would do is I'd actually use a debugger and I'd put a watch point in or something along those lines to actually see how different variables are changing and get a trace of the output. Another thing I'd be tempted to do would just be like return num elements below I and that sort of thing to like basically effectively make the output from the debugger. So I'm not going to do that. That would probably help me tremendously if I did. It's really tempting. So instead, I want to check this get meeting if exact range thing. So my number outside, if my I range in this case is 0 to 2. I should end up with 2, right? So I should end up with two outside of I. So I range 0 is 0 plus I range 1 is 2. And I'm inside, I should end up with 1, right? So I have a size of 3. Outside is 2, I end up with 1. Start of I range should be I range 0 plus 1, so 1. Oh, no, that's an off by 1 bug, isn't it? Why did I think that was plus 1? This should be so start of I range should just be the number of elements that I have for it, the size of those. So in this case, it's 0. The end should be total length of defined array. So I should have coming after it. So this is 3 minus 2 is 1. So that should be minus 1. And then same story here. Start of I range. So I'm just trying to walk myself through these. So in this particular example, we've got for the I range, it's going to be 0, 1. Sorry, 0, 0. So the start and the end are the same. It's an inclusive range. So here, J, it's going to be 1, 2. So this should be 1, this should be 2. Let me double check that that's correct. So I've got 0, 2 for those values. So num outside of J. Sorry, 1, 0. So num outside of J plus 0 is 1. Side is going to be 2. that should be 1, which is correct because the first element. And size minus 0 is going to be 3 minus 2. The last piece of element is going to be that. Cool. And then this should all be correct, I think. Start of I is equal to the lower median index and the end of upper. Turn start value and value divided by 2. Start of j. This is all. You have to check before. Since I changed something, I'm just going to run it, see if that fixed my problem. Looks like it. This is so much easier to do as an order n. I got the order n side of this in like, I don't even know, 15 minutes or something. Oh. So either way, that should be coming back null. My I range 0. 0. In this case, if that's greater than upper median x, my upper median x is going to be 1. Not greater than 1. I range. Oh, okay. So here's where I'm screwing up. I need. I really just need these variables inside of there. This is ugly. I'm just going to do this though. All these return values are duh. Those are duh comments. I don't really add those. So what I'm looking for here, I range 0. This should be actually start of I range. So if the end of my range is lower than, yeah, it should be start of J range. And this should be J range. But this is a weird thing. So like in this case, it'll work fine. Or that should work fine because like this is definitely fully below the median range. I'm just worried about like what happens if they both end up looking like this. Like we end up with this situation. That's going to be that's not the situation we should be in right now. But I'll see if I can actually try to force that in a minute. Am I still getting an infinite loop? Why am I still getting an infinite loop? So my start of I range is definitely not above the median. Start of my end of my I range is definitely below the median. So like that should branch here. What's my previous upper I? -1.length. That's the total size of I. So like it should branch here and say I. My current I is 0 plus, what is it? Crap, was that -1 up here? So I've got a length of 2. So should be 0. It should be 1 divided by 2. Oh. Yeah. Uh, should it not be math.floor? Should be math.round. Just I think I've been trying to do this problem for too long, so I'm like losing my short-term memory right now. So we got this is definitely length is 2 -1 gives me 1. This gives me 0 plus 1 is 1 divided by 2, 0.5. It's going to give me 0, which is going to be the same value that I had before. So this is why I'm looping. I can try math.round. I just wonder if that's not going to introduce other fun issues. Or later. I also don't remember if math.round is I don't remember if it works straight off or what. It's cool. I have a feeling this is just going to cause problems later. Let's see. Still, it seems to be looping infinitely. So, so let me just keep working it. So like here, I would have had, this would have given me, caused I to go from 0 to 1. So, sorry, this should have been. I was listing this as though it was the dereferenced values before, not the actual index, like not the actual value of I, but like 2j. So for the next step, it's going to be I is 1, j equals 0. But actually, I should keep going here and see, like, maybe I should be saying continue at some point. I do if start of j range, sorry, less than up. So my start of j is going to be which is not greater than upper median of end of J range is also 1, which is not less than my. So yeah, continue is not necessary there. But let's go on here and see. So I range to so I know I've got 2 items smaller than no items larger. J range is equal. No, from before I had 1 item smaller than my J. Should now have larger than my J, so I should have 1. Actually, hang on. And then oh, wait a second. Am I ever storing my ranges back into this? So I've got ranges I, ranges J. Oh, wow. Yeah, that'll do it. Helps if I actually terminate my while loop, you know, after I set up my, after I change around my iterators. Size. It was like total length, yeah. All right, that's infuriating. I was really hoping that. So if you didn't catch that, I had a curly bracket. It was like so. So I opened my while loop here at line 25. I had closed my while loop at line 53 here, which was right before I basically did all the stuff that updates the I and the J value for duration. Sorry, I'm also seeing that maybe the stream's gone down. It looks like it might have gone down the machine. No, okay, it's still alive. It's just my top was being sad. So that did not fix it though. Like just in making sure that I included all this junk. I probably should take a pass through it, cleaning this up a little bit. Just like there's definitely now. Oh, right. So this is going to be a problem too. I just identified that over here. So like back over here when I was saying like, oh, I know from before that this is a 1. I'm actually overwriting that every single time. Which is bad. I should not be overwriting every single time. Instead, this is just all plain wrong right there. So number of elements above I is going to be 2. Number of elements below, let me start from here. So number of elements below I range oh, above is going to be I range 1. And elements below J is going to be J range 0. Elements above is going to be I range 1. This is going to be J range 1. This is J range 0. I range above 0. I'm a little worried that I might have another off by 1 in there, but I just need to do this. Num elements below I. I range 1. It's above J range 1. Cool. That makes it a hell of a lot less readable though, which makes me sad, but I mean, so now that I'm not overwriting things in every single time, I think it's still running in turns pretty. I am very confused as to why I'm still infinitely looping here. Just looking at the bounds of the nation, that should be fine. So initializing this is fine. 0 above, 0 below, meaning like actual range is higher combined array. I'll know for I and j, there's always I elements below. Nums1 dot length is I. So if I'm line and above, second element, okay, makes sense. So that also makes sense there. Nums1 on the nums2. So this is saying if I is less than j, if the number at I is less than the number at j, then I can say that because j is larger than I, j and everything in the j array, it's larger than j. It's also larger than So what that means, I range, I know that there are now as many elements that are bigger than j are also bigger than I, plus j itself, so plus 1. Similarly, in reverse, I can say as many items that there are that are smaller than I are also smaller than j plus I itself. Here, saying the exact opposite. So when I is bigger than j, I'm saying the number of items that are smaller than j plus j itself are smaller than in combination with the items that I already know to be smaller than. Oh, sorry, I just realized. I think because I'm doing this here, I think I'm still overwriting this value. So like, I was doing this iteration before. We initialized to 0, 0, and said that j is larger than I, or value at j is larger than I. So therefore, there's at least one item smaller than j in the final range. So I captured that here, and then move forward. Did other stuff, and then move forward iterating. The only thing I could iterate was I greater than, I now shifts over to being 1. And so when I'm evaluating j, context of I, or in the context of of 3. So I'm evaluating this 2 in the context of this 3. I'm able to say that this is, because this is less than that. I can only say this only tells me something about what's bigger than j. It doesn't tell me anything about what's less than j. And so, but I need to capture this value here for. But over here, in the way that I'm initializing things, I'm still overwriting that. So what I need to do is, so in this case, my j range, I'm initializing the first value to be j, which is 0. What I need to do is initialize to be the greater of which of the two. So like either j. Is there like math.max in JavaScript? Hooray, okay. So I need to do math.max I range math.max What are we upset about here? That's hopefully a good sign, actually. Hopefully. Oh, I got a bug there, don't I? This should be previous lower j or previous upper j equals i's j. There's an ever so slight chance that was the problem that caused it to run infinitely. I don't think it was, though. All right, I've been at this for a couple of hours. So it's 7:02 p.m. right now. I'm probably going to give this another like 10 or 15 minutes. Like I'll give it another pass or two. Probably going to just call it. As a reminder, I did have a submission that worked, but it just wasn't. It didn't meet this time complexity thing, and I'm like 99.9% sure that this algorithm overall is correct. So like I don't feel like this is a total failure, but because I'm not able to get it running and executing perfectly, um, it's certainly not a success either. Um, so yeah, I'm just gonna take another pass quick, see if anything else jumps out at me as like horrendously terrible. And if it does, I'll try that, and hopefully maybe it'll fix it. But yeah, so I feel pretty comfortable with the way all this initialization is working. Um, yeah, I feel pretty comfortable with all of this. Comfortable with the iteration check and initializing J range now. Um, so, but this is telling me is like what I'm doing here with the max value is I'm making sure that I'm choosing whichever value constrains things the most. It's like it's I'm calling these ranges, but they're like really inverse ranges. It's like the number of elements outside the range, comma like to the lower side, comma the number of elements outside the range to the upper side. But I think that this is fine here overall, and so I just checked through this. I'm feeling pretty confident about that. Um, Feeling good about this. Like this is enough to differentiate, or to make these two not collide, basically. So I don't think that's a bug. Um, so again, these ranges are tracking everything that's outside. So I just add these two together to compute their outside I. Similarly, to calculate the number of elements inside, I just take the total number of elements and subtract the number outside, which tells me the starter range of I range is equal to the number of elements outside of I below. So that's basically one, the last index of the elements outside, so that should be fine. And then end should be equal to the number of elements outside above the range that we want, subtracted from the total length. So if there's, say we have 5 elements, we have 1 above our known range for I, that should give me 4. But because this is an index, I need to subtract 1 to so the last value of the range is what this, or the last index of the range this is telling me. And so I have to subtract 1 there. So that's fine. J range, this all matches here. I probably should have a function that's computing this for me. I don't even know if I'm using this num inside anymore. Not at either. So I can just simplify things there. So my median is covered entirely by I range. So if the start of the range is X and the end of the range is upper median X, I turn nums1 start plus nums1 end 2. Same thing here for J, so I'm just going to check this is matching J's and I's, and then that's the case. Now, if our median is covered entirely by I and J range, find where I is equal to lower median index and J is equal to upper median index. So this is like, this only works if I only have one value in my range for I and one value in my range for J. So that's why I have these checks for start equals end for both of these. So start I equals end I, or NJ, I mean, sorry. And just to be consistent with the case, checking start of the I range is to be equal to lower median index, end of the J range, upper median index. That's the case. Well, actually, there's a bug here because these indexes are wrong. This should just be I. Wait, what should this be? This is a bug because like I'm using the start of the range is like this is an index relative to a merged array, and I need to be finding that index in the nums1 array, which is just a piece of them. So yeah, I think I'm going to give up at this point, which kind of sucks. I apologize for that, but I need to go eat dinner and I don't know, contemplate my life choices or something. Either way, like I do truthfully feel like I'm on the right track for this. Again, like this process of basically using a sort of like double binary search to kind of hone in on these ranges, like for where each number fits into the actual like bind merged array. I think that will work at the end. But I think I just need to kind of come back at this when I'm fresh and blood sugar is a little bit more in the normal range, and it's not 7 o'clock at night. Hopefully this has been kind of entertaining though to watch for whoever's still watching, and really appreciate that. If you want to see more of this, I'm definitely going to be doing more of this for better or worse. Like hopefully this isn't ruling out my ability to get a job somewhere, but you know, feel free to subscribe, and you'll definitely see some more of this kind of content soon. So yeah, if you like seeing people punish themselves, click that subscribe button. Thanks a lot, everybody.